Welcome to GEDprep AI Tutor. In this video, we're going to tackle a common question type on the GED science test: data analysis in experiments. Let's start with the first question. We're asked the average time it took for the solvents to reach equilibrium. Let's check out the experiments. Consider a substance, such as salt or sugar, dissolved in a liquid, like water or alcohol. The liquid in which the chemical is dissolved is known as the solvent. Osmosis is the movement of a solvent through a semi-permeable membrane. The solvent flows from the side of the membrane with the least dissolved material to the side with the most dissolved material. Osmosis produces an equilibrium, which is the rate at which the solvent flows across the membrane in both directions. Jillian ran an experiment to determine how quickly various liquids, containing a given amount of sugar, would undergo osmosis. She used vats of the same size, separated by semi-permeable membranes, and filled both sides with equal amounts of various liquids. Focus on the keywords, table above, and average time. That means we'll use the data shown here and find the mean value. Now, look at this column. Time required to reach equilibrium. The values are 20, 25, 18, and 15 minutes. These are the numbers we'll use to calculate the average. Let's add them step by step. 20 plus 25 equals 45. Add 18 to get 63. Add 15 more and you have 78. Now, divide that total by 4. Because there are 4 solvents, 78 divided by 4 equals 19.5 minutes. So the correct answer is C. Let's move to the next question. It asks, would Luke's survey give accurate results if only half his soccer team responds? 2 keywords, accurate results and half his soccer team. Let's read the survey. Luke is conducting a poll to see how effective his high school's vending machine ban has been at reducing the quantity of junk food pupils consume. The study asks students how much junk food they used to eat and how much they consume now. Luke distributes the survey to the players of his soccer team, many of whom used to grab a snack from the vending machines after practice. Accuracy depends on whether the sample represents the whole school. Surveying only the team is a non-random sample, not representative. Now examine the options. A. Yes, because some use the vending machines. This is wrong because prior vending machine use doesn't make a biased, non-random sample representative. Who you survey matters more than whether some happen to use the machines. C. Yes, because the team members come from diverse backgrounds. Diversity sounds good, but it's still one team. It isn't randomly selected from all students. D. No, because Luke didn't survey them before the machines were removed. Timing comparisons matter, but because the questionnaire already asks about before and now. So a true pre-ban survey isn't required for this design. B. No, because the survey is not a random sample of the relevant population. Only surveying his soccer team and only half responding means it doesn't represent the whole school, so the results aren't reliable. To conclude, the main problem with Luke's survey is that he distributes it only to his soccer team. This group is unlikely to be representative of the high school's pupils as a whole, who are the relevant population for evaluating the vending machine ban. Soccer players might have different dietary habits, exercise routines, or snack needs that distinguish them from the general student body. Therefore, the sample is biased, and the results cannot be accurately generalized to the entire school, regardless of the response rate. So the correct answer is B. The following question asks, how did the office manager set up her experiment? Not the hypothesis, not what she did after, just the setup. Let's break down the experiment. An office manager noticed that she often experienced electrostatic shocks when touching a metal filing cabinet, while her assistant rarely did. Curious about the cause, the manager hypothesized that her clothing might be the reason, as she wore nylon clothing, and her assistant typically wore cotton. To test this, the manager had her assistant wear nylon clothing for a week while she wore cotton. The following week, they swapped clothing. They controlled for shoe differences by wearing identical footwear. After a week, they recorded the number of shocks each had experienced. The results showed that the manager had fewer shocks when wearing cotton, supporting her hypothesis that her clothing played a role. Now examine the options. A. The office manager wore shoes of a different material. That contradicts the passage. Footwear was identical to control that variable. B. She suspected nylon was the cause. That's just the hypothesis, not the experimental setup. C. She switched to cotton after seeing her hypothesis was supported. That's a post-experiment action, not the design. D. She wore one type of clothing while her assistant wore another, and they recorded the number of shocks. That describes the setup exactly. Alternate fabrics, control shoes, measure shocks. So the correct answer is D. Look at the fourth question. What variable is being controlled? We're looking for things kept the same for both groups. Let's turn to the experiment setup. An agronomist wants to test whether adding organic compost increases the growth rate of tomato seedlings. She plants two groups of 10 seedlings in identical pots. One group receives a standard soil mix, and the other receives the same mix plus compost. All other conditions, light, water, temperature, are kept constant. After 4 weeks, she measures stem height. In an experiment, a controlled variable is a factor that is kept consistent across all groups to ensure that any observed results are due to the manipulated variable, the independent variable. Now look at the answer choices. A. Stem height measurement. This is the dependent variable. It is the outcome that the agronomist measures to see if the compost had an effect on growth. It's what's being observed, not what's being kept constant. C. Addition of compost. This is the independent variable. It is the factor that the agronomist changes or introduces to one group, compost, but not the other, standard soil mix, to observe its effect. D. Amount of compost added. That's still part of the independent variable, not a constant. B. Amount of water and light. The passage states that the agronomist kept all other conditions, light, water, temperature, are kept constant. Therefore, the amount of water and light are explicitly identified as controlled variables. So the correct answer is B. And the last one. Why does Ben have insufficient proof for his conclusion? Ben conducted an experiment to demonstrate that ivy plants absorb water through their roots. He placed an ivy plant in an open jar, filled it with water just covering the roots, and observed it after a week. He noticed the water level had decreased, leading him to conclude that the plant had absorbed the water through its roots. The key phrase is insufficient proof. We need to find what's missing in his design. Ace. Ben should have put more ivy plants in the open jar. More plants don't solve the flaw. They'd all still lack a control for evaporation. B. There should have been soil in the jar rather than water. Soil isn't required to test root water uptake. That doesn't address the alternative explanation. D. Ben should have put several plants of different species in the open jar. This adds new variables and makes the test less focused. C. The water level might have gone down because of evaporation. For an experiment to provide conclusive proof, it must control for all other variables that could explain the observed result. In Ben's experiment, the jar was open. Water can evaporate from an open container, meaning the decrease in water level might not be solely due to the plant absorbing it through its roots. Ben needed a control group, e.g. an identical open jar of water without a plant, to measure evaporation and subtract it from his observed decrease. The source states, because the experiment did not control for evaporation, it does not prove that the water was absorbed by the ivy, so the correct answer is C. Thanks for watching. Don't forget to like, share, and subscribe to our channel for more interesting lessons and practice tests. You can also download GEDprep AI Tutor from the App Store and Google Play to access more materials.